All right, the 3.2 is the section on negative exponents. And when you have a negative exponent, our goal and your directions will always tell you to always write in positive exponent form. You never want to have a negative exponent in your answer, just like you don't want to have a 1 in front of your x or an x raised to the first power or something like that. So anytime you have a negative exponent, a to the negative n, to rewrite it in positive form, you just bring it to the bottom of a fraction. So remember, if you have whole numbers, like if you had a 3, that's the same thing as 3 over 1. So the reason why we're bringing it to the bottom of the fraction is because even though it's not written, it's on the top of a fraction here. So if I had x to the negative 3, to make that negative 3 positive, I'm bringing it to the bottom of that fraction. Sometimes you have the negative exponents written on the bottom. Like this one, I have 1 over a to the negative n. I know this is hard to read because I have it, again, printed from your e-text. So if you can't see that, it's 1 over a to the negative n. And if you want to make that positive, since it's on bottom, you bring it to the top of a fraction. So if it's on the numerator, you bring it to the denominator. If it's in the denominator, you're going to bring it to the numerator. So why does this work? Just because when we have that quotient rule, if we had the same base when we're subtracting our exponents, so what actually is happening here, if I subtracted 7 minus 3, I would get x to the 4th, right? Well, here, if I subtracted 3 minus 7, think of it like this, x to the 3 minus 7. This is the same thing as your sign rules. I had different signs. I'm subtracting, taking the sign of the bigger number. The bigger number is negative, so my answer is negative. So that means that I'm actually getting negative exponents because of my quotient rule. Sometimes when you have a quotient, if the bigger number is not on top, you're going to get a negative exponent. So our negative exponent rules, the reason why they work out this way is just like when we had our quotient rule, you could have 7x's on top. So I have 3, 5, 6, 7. And 3 on bottom. And when I cancel out everything, I'm going to be left with 4 on top. The same thing here. If I have 3 x's on top and 7 on bottom, if I cancel out what they have in common on top, I'm going to be left with x times x times x times x, which is x to the 4th. And notice that if I have x to the negative 4, that's the same thing as having 1 over x to the 4. So notice that these two examples, or these two parts, are written in positive exponent form, whereas this right here, if I just use my quotient rule and subtract, it automatically puts it in negative exponent form. And to make that negative exponent positive, we have to move it to the bottom of a fraction. So x to the negative 4 is the same thing as 1 over x to the 4. And again, using our quotient rule in expanded form, you can actually see why that's the case. So just if you have to have that rule, or if you need to see that expanded just to get this straight in your mind, that's what I would suggest you do. Now this is a summary of all of our exponent rules that we've had so far, and we're fixing to get into some tougher problems where we're going to have to do a little bit more than just one exponent rule at a time. So I want you to use these steps for simplifying your exponents. You always want to use your power rule first if it's hindering you from doing a lot of your other exponent rules. Then you want to get rid of your negative exponents. And then last, you want to simplify using your product rule to get one of the variables on top with the same base, one of the variables on bottom with the same base, and then you can use your quotient rule. So I'm going to keep these at the top, and we're going to start working our problems. All right, our first example says simplify, and it has x to the negative 4. So if I have x to the negative 4, to make it a positive exponent, I'm going to write it on bottom of my fraction. So x to the negative 4, I'm bringing it down, and I get x to the positive 4, 1 over x to the positive 4. Okay? That's all you're doing. You're just writing it in positive exponents, and that's it. Now here, I have a number. So if I have a negative exponent and it's a whole number, I'm moving it to the bottom. So that'll be 1 over 2 to the third. And 2 to the third, that's 2 times 2 times 2, which is going to give me 8. So 1 over 8 is in simplest form. Now this next example, I have 5 to the negative 1. If I have that negative exponent to make it positive, again, I bring it down. And remember, if I have 5 to the positive 1 on bottom, that's the same thing as just having 1 over 5. Okay? Now this is going to be fun. Because we have an addition sign, this is going to be a fraction. So I have 5 to the negative 1. That's going to be 1/5. 3 to the negative 1 is going to be 1/3. And I'm going to get a common denominator. So what would be a common denominator between 5 and 3? Well, 15. I want to get them both to be 15. So if I multiply this top and bottom by 3, 5 times 3 is 15. So if you didn't know what to multiply by, you could ask yourself, what times 5 gives you 15? Well, 3. So I'm going to multiply the top and bottom of that fraction by 3. 1 times 3 is 3, and then check. 5 times 3 is 15. Do the same thing for this one. I want 15 as a denominator. I have 3, so what can I multiply times 3 to get 15? And it's 5. So I'm going to multiply the top and bottom by 5. So 1 times 5 is 5, 3 times 5 is 15. So I want to keep that denominator the same, and I'm going to add my numerators. Now, unlike when you multiply fractions, you're not guaranteed that this is in simplest form. You can't do a cross canceling or anything like that. So the factors of 8 is 2, 2, and 2. The factors of 15 is 3 and 5. There's nothing they have in common, so this is in simplest form. Now I'm going to stop the video here, and we're going to pick up on number 5 on the next video.